April 27th, 1945. Somewhere along Highway 62, near the village of Schwanfeld, southern Germany. 11:15 in the morning, Technical Sergeant Robert Earley crouched behind the engine block of his disabled M4 Sherman tank, binoculars raised, studying the massive shape that sat motionless 300 yards down the road. The thing's enormous, bigger than anything we've seen. His hands trembled slightly, not from fear, but from the adrenaline that came with spotting enemy armor. Through the morning haze and dust kicked up by the advancing American column, he could make out the angular lines of what he initially assumed was another German heavy tank. But as the dust settled and the sun broke through the overcast sky, Early realized this wasn't just another Panther or Tiger. This was something else entirely. The turret alone looked larger than his entire Sherman. The gun barrel stretched forward like the arm of some industrial crane, impossibly long and thick. The hull sat low and wide, its frontal armor sloped at severe angles that seemed designed by engineers who had forgotten that tanks needed to move, not just exist as mobile fortresses. Yet the tank wasn't moving. No engine smoke, no dust from treads, no gun traversing to track the American column that had stopped warily at the edge of effective range. The German tank just sat there, angled slightly off the road, its gun pointed toward a tree line, as if it had been abandoned mid-engagement. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. Lieutenant James Morrison, commander of the lead tank platoon, moved up to Early's position in a low crouch. He carried a map case and a growing sense of unease. Every instinct developed over 8 months of combat from Normandy to Germany told him something was wrong with this picture. German tanks didn't just sit in the open. They ambushed from concealment. They fired from defilade positions. They retreated when outnumbered. They did not park themselves broadside on a main road and wait for American armor to arrive. Morrison raised his own binoculars and studied the vehicle carefully. The identification markings were unmistakable once he knew what to look for. The Balkenkreuz, the German cross insignia, was painted on the turret side. The Zimmerit anti-magnetic paste coating gave the armor a distinctive textured appearance. The interleaved road wheel arrangement, a signature of German heavy tank design, was visible even from this distance. But the sheer size of the vehicle exceeded anything in the intelligence briefings Morrison had received. "Is that a King Tiger?" Morrison asked quietly, more to himself than to Early. Early lowered his binoculars and looked at his lieutenant. "If it is, sir, it's the first one our battalion's seen. The intelligence boys said they were rare. Only a few hundred built." Morrison nodded slowly, his mind already working through the tactical problem. The Tiger II, called Königstiger in German and nicknamed King Tiger by Allied forces, represented the pinnacle of German tank design and the absolute nadir of German industrial reality in the final year of the war. The vehicle Morrison and Early were studying had been designed to be invincible. In some ways it was. In other ways, it was a mechanical nightmare that exemplified everything wrong with German late-war weapons development. The Tiger II traced its origins to 1942, when German tank designers began conceptualizing a successor to the Tiger I. The original Tiger, despite its fearsome reputation, had revealed limitations during combat on the Eastern Front. Its flat armor plates, while thick, were vulnerable to increasingly powerful Soviet anti-tank guns. Its weight of 57 tons strained bridges and roads. Its complex overlapping road wheel design trapped mud and froze solid in winter. The Maybach engine, adequate when the tank was designed, struggled to move the increasing weight. German engineers proposed a solution that would address these problems while creating an entirely new set of difficulties that would make the Tiger II simultaneously the most powerful tank of World War II and one of the most operationally useless. The design specifications called for revolutionary improvements over the original Tiger. The armor would be dramatically thicker and sloped to maximize deflection of enemy rounds. The main gun would be the longest, most powerful tank cannon ever mounted in a production vehicle. The hull would be wider and longer to accommodate the larger turret and provide better weight distribution. The designers succeeded brilliantly in creating a tank that could destroy any Allied armor at ranges exceeding 2 miles, while remaining essentially invulnerable to return fire from the front. They also created a 70-ton monster that broke down constantly, consumed fuel at catastrophic rates, and required industrial infrastructure that Germany no longer possessed to maintain. The frontal armor of the Tiger II was 180 millimeters thick, sloped at 50 degrees. This combination provided effective protection equivalent to nearly 300 millimeters of vertical armor. No Allied tank gun in 1945 could penetrate this armor from the front at combat ranges. The turret front was even thicker, 185 millimeters of steel, sloped and curved. From the front, the Tiger II was effectively immune to everything the American, British and Soviet armies could fire at it. The side armor, 100 millimeters thick on the hull and 80 millimeters on the turret, remained vulnerable, but still far exceeded the protection of any Allied tank. Even the rear armor, 80 millimeters thick, was heavier than the frontal armor of most Allied medium tanks. The main armament was equally impressive. The 88mm KBUK 43L-71 was the most powerful tank gun mounted in any production tank during World War II. The designation indicated the caliber, 88mm, and the barrel length, 71 times the caliber, resulting in a gun tube over 20 feet long. The sheer length of the barrel generated enormous muzzle velocity. The standard armor-piercing round left the barrel at over 3,000 feet per second. At 1,000 meters, this projectile could penetrate 237 millimeters of armor plate. At 2,000 meters, it could still penetrate 185 millimeters. These numbers meant the Tiger II could destroy any Allied tank, including the heaviest Soviet IS-2s and American M26 Pershings, at ranges where return fire was impossible. German tank doctrine emphasized the Tiger II's role as a long-range sniper. The vehicle would take position in a concealed location with good fields of fire. It would engage enemy armor at maximum range, destroying tanks before they could approach close enough to threaten the Tiger. The combination of invulnerable frontal armor and devastating long-range firepower made the Tiger II theoretically unbeatable in open terrain. The reality proved far different. The same features that made the Tiger II so formidable also made it operationally crippling. The 70-ton weight exceeded the capacity of most bridges in Europe. German engineers had specified that all bridges along major routes must support 50 tons, but 70 tons exceeded this limit by 40%. Tank commanders had to route their Tigers around bridges using fords or heavy-duty railroad bridges, which restricted mobility and made movement predictable. The weight also exceeded the capacity of most German tank transporters. The Tiger II was supposed to be transported to the combat zone by rail, then driven only the final distance to preserve the engine and transmission. But Allied air superiority meant railroads were constantly under attack. Trains carrying Tigers became priority targets. As the front lines moved deeper into Germany, fewer railroads remained operational. More Tigers had to drive longer distances, accelerating mechanical failures. The interleaved road wheel suspension system, retained from the Tiger I despite known problems, proved even more troublesome on the heavier Tiger II. The system used overlapping road wheels arranged in a complex pattern that distributed weight more evenly and provided better ride quality. Each side of the tank had 9 road wheels arranged in 3 rows, overlapping like scales on a fish. The inner wheels were mounted on separate axles from the outer wheels. This design provided excellent weight distribution and a smooth ride, but created maintenance nightmares. If an inner road wheel was damaged or broke, the entire outer row of wheels had to be removed to access it. This process could take an entire day with proper tools and a maintenance crew. In combat conditions, with limited tools and exhausted crews, it was often impossible. The overlapping wheels also trapped mud, snow, and debris between them. In winter conditions on the Eastern Front, this mud would freeze solid overnight. Crews would wake to find their tanks immobilized, the frozen mud locking the suspension completely. The only solution was to build fires under the hull to melt the ice, a process that took hours and revealed the tank's position to any nearby enemy. The engine and transmission represented the Tiger II's greatest weakness. The Maybach HL 230 P30 gasoline engine produced 700 horsepower, an impressive figure by 1944 standards. But 70 tons divided by 700 horsepower yielded a power-to-weight ratio of 10 horsepower per ton, barely adequate for a vehicle expected to maneuver in combat. By comparison, the American M4 Sherman, weighing 33 tons with a 450 horsepower engine, had a power-to-weight ratio of nearly 14 horsepower per ton. The Sherman was more agile, more responsive, and could accelerate faster despite being much lighter. The Tiger II's top speed on roads was theoretically 25 miles per hour. In practice, commanders rarely pushed the vehicle above 15 miles per hour because higher speeds accelerated wear on the overtaxed transmission and final drives. Cross-country speed dropped to perhaps 6 to 8 miles per hour. The Tiger could lumber forward through mud or across fields, but it moved at a crawl compared to lighter Allied tanks. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now back to the story. The transmission was a catastrophe of over-engineering. The Maybach Olvar 40B pre-selector gearbox was a sophisticated piece of machinery that provided 8 forward gears and 4 reverse gears, allowing the driver to select the optimal gear ratio for any speed or terrain. In theory, this gave the Tiger excellent control. In practice, the transmission was fragile, prone to failure, and required constant adjustment and maintenance. The final drives, the gearing that connected the transmission to the drive sprockets that moved the tracks, bore the full burden of moving 70 tons of steel. These components failed regularly, sometimes after just a few hundred kilometers of operation. When a final drive failed, the tank was immobilized. Replacing a final drive required specialized tools, lifting equipment, and skilled mechanics. The repair could take several days under ideal conditions. In combat conditions, or in the field, it was often impossible. German maintenance records show that final drive failures were the single most common cause of Tiger II mechanical breakdown. Some tanks never reached the front line, breaking down during the journey from the factory or railhead. Others fought one battle, then suffered final drive failure and had to be abandoned. The fuel consumption defied logic. The Tiger II's Maybach engine, labouring to move 70 tons, consumed fuel at rates that made the vehicle operationally unviable. Under ideal conditions, driving on roads at moderate speed, the Tiger II managed approximately 1 kilometre per litre of fuel, or roughly 0.6 miles per gallon. During combat operations, with frequent acceleration, gear changes, and engine idling, consumption could drop to 0.5 kilometers per litre or worse. The Tiger II's fuel tanks held 860 litres, theoretically providing a range of 170 kilometers on roads. In practice, combat operations reduced effective range to perhaps 100 kilometers or less. Refueling required finding an intact fuel depot, which became increasingly rare as Allied air forces destroyed German logistics. Infrastructure. Each Tiger II required its own fuel truck to keep operating. Supplying a company of Tigers required diverting fuel from other units, straining the already collapsing German logistics system. The manufacturing complexity meant production could never meet demand. Hitler had ordered thousands of Tigers built. German industry managed to produce only 489 Tiger IIs between January 1944 and March 1945. Each tank required approximately 300,000 man-hours to build, compared to roughly 10,000 man-hours for a Sherman or T-34. The Tiger II used precision-machined components that required skilled craftsmen to manufacture. As Allied bombing destroyed German factories and killed or displaced workers, finding the skilled labour to build Tigers became impossible. The steel required for one Tiger II could build several Panzer IVs or assault guns, vehicles that were easier to build, easier to maintain, and more strategically useful. But Hitler and many German officers remained obsessed with quality over quantity, believing that superior technology could offset numerical inferiority. The Tiger II exemplified this philosophy and demonstrated its failure. Raw materials became critically scarce by late 1944. Germany had lost access to chromium supplies from the Balkans, molybdenum from Norway, and nickel from Finland. These alloying elements were essential for producing the high-quality armor steel that made the Tiger's protection possible. German metallurgists tried substituting alternative materials and adjusting steel formulations, but the quality of late-war German armor declined noticeably. Some Tigers, built in early 1945, had armor that cracked under impact rather than deforming, a catastrophic failure mode. The Zimmerit coating applied to German tanks from late 1943 through September 1944 added another layer of complexity. Zimmerit was a paste consisting of polyvinyl acetate, zinc sulfide, and barium sulfate that was applied to armor surfaces and then textured to create a rough finish. The purpose was to prevent magnetic anti-tank mines from adhering to the hull. In practice, magnetic mines were rarely used, making Zimmerit largely unnecessary, but applying it required additional time and labor at the factory. Each tank needed to be coated, the Zimmerit had to cure, and then the vehicle could be painted. The process added several days to production time for minimal tactical benefit. Quality control collapsed as Germany's situation deteriorated. Tanks were rushed from factories with incomplete final inspections. Some left assembly lines with known defects that were supposed to be corrected by field units, but those corrections often never happened. Spare parts became scarce, then critical, then essentially non-existent. By early 1945, German tank units were cannibalizing broken tanks to keep a handful operational. 3 or 4 Tigers would be stripped of parts to keep one running. The operational readiness rates for Tiger units in the final months of the war were catastrophic. Heavy tank battalions were supposed to field 45 tanks. In reality, having 15 operational tanks was considered good. Having 20 was exceptional. Many battalions reported single-digit readiness. The famous 503rd Heavy Panzer Battalion, one of Germany's most experienced Tiger units, reported in March 1945 that it had 7 operational Tiger IIs from an authorized strength of 45. The other 38 were broken down, awaiting parts, or had been destroyed or abandoned. Training for Tiger crews became increasingly inadequate as the war progressed. Early Tiger units received extensive specialized training on the vehicle's complex systems. Drivers learned the intricacies of the pre-selector transmission. Gunners trained on the sophisticated optics and range-finding equipment. Commanders studied tactics for employing the Tiger's strengths while minimizing exposure to its weaknesses. By 1945, training time had been cut drastically. New crews received minimal instruction before being sent to the front. Some drivers had only a few hours of experience with the Tiger's unique transmission before being committed to combat. Inexperienced drivers made mistakes that broke transmissions or final drives. Inexperienced commanders made tactical errors that negated the Tiger's advantages. The Tiger II's radio equipment was sophisticated but power-hungry. The primary radio was the Fug 5 for inter-tank communication within the unit. The command tanks also carried Fug 8 for communication with higher headquarters. These radios provided excellent communication when working, but required substantial electrical power. The tank's electrical system, already burdened by turret traverse motors, gun elevation systems, and engine accessories, struggled to keep the radios powered during extended operations. Dead batteries were a common problem, leaving tanks unable to communicate. The crew conditions inside the Tiger II were simultaneously better and worse than other tanks. The large interior provided more space than most vehicles. The 5-man crew, consisting of commander, gunner, loader, driver, and radio operator hull machine gunner, had room to move and store equipment, but the massive engine and transmission generated tremendous heat. In summer, the interior could reach temperatures exceeding 40 degrees Celsius, 104 Fahrenheit. Ventilation was inadequate. Crews fought exhaustion from heat as much as from combat stress. The noise inside the Tiger during movement was deafening. The engine roar, transmission, whine, and track clatter made communication without the intercom system nearly impossible. Crews wore padded leather helmets that provided minimal hearing protection. Prolonged exposure caused permanent hearing damage. The gun's recoil, despite the sophisticated recoil mechanism, rocked the entire vehicle. Firing the main gun was a violent experience. The blast pressure inside the turret, even with the breech sealed, caused discomfort and temporary hearing loss. Loaders had to handle 88mm rounds, weighing up to 28 kilograms, 62 pounds, and load them into a breech positioned high on the turret's center line. Loading the gun required strength and stamina, and the loader's position was one of the most physically demanding jobs in any tank. The ammunition storage arrangements prioritized protection over accessibility. The Tiger II carried 84 rounds for the main gun, a relatively small load for such a large vehicle. The rounds were stored in armored bins distributed throughout the hull and turret. Accessing rounds from the lower hull bins required the loader to partially leave his position and bend down into the confined space. The rate of fire slowed as the ready rounds in the turret were expended, and the loader had to retrieve rounds from less accessible locations. The gunner's position featured excellent optics, among the best in any wartime tank. The TZF-9B telescopic sight provided 12.5 times magnification and a precise reticle for range estimation. In the hands of a well-trained gunner, the Tiger II's accuracy at extreme ranges was phenomenal. First-round hits at 1,500 to 2,000 meters were achievable against stationary targets, but the sophisticated optics required careful maintenance and were vulnerable to shock and vibration. A rough journey over broken terrain could knock the sight out of alignment, reducing accuracy until it could be recalibrated. The commander's cupola provided excellent visibility with 7 periscopes, offering 360-degree vision. The cupola could rotate independently of the turret, allowing the commander to scan for threats, while the gunner remained focused on a target. But the cupola's prominent profile made it a target for enemy gunners and snipers. American tank crews and infantry learned to aim for the commander's cupola, knowing that disabling the tank commander severely degraded the crew's effectiveness, even if the tank itself remained operational. The hull machine gun, a 7.92mm MG-34, was operated by the radio operator. This weapon provided defense against infantry at close range, but its usefulness was limited. The fixed mounting and restricted traverse meant the gun could only engage targets directly in front of the tank. The position was also the most dangerous in the crew. The radio operator sat directly in line with the hull front, the area most likely to be struck by enemy fire. Even though the Tiger's armor was thick, a penetrating hit at the radio operator's position was usually fatal. The Tiger II's tracks were 1 meter wide, substantially wider than most tank tracks, distributing the vehicle's enormous weight to reduce ground pressure. Despite this, ground pressure still exceeded 1 kilogram per square centimeter, much higher than lighter tanks. This meant the Tiger struggled on soft ground where lighter vehicles could operate. Muddy fields, sandy terrain, and marshy areas all posed serious mobility problems. Tanks would sink into soft ground, the wide tracks churning mud but finding no purchase. Recovery required other Tigers or heavy recovery vehicles to pull the stuck tank free, operations that took hours and exposed vehicles to air attack. The lack of adequate recovery vehicles compounded these problems. The Germans designed the Panther, a recovery vehicle based on the Panther tank chassis, to recover broken-down tanks. But the Panther struggled to recover a 70-ton Tiger II. The weight exceeded the recovery vehicle's capacity. Recovering a Tiger required multiple Panthers, working together or specialized railroad cranes, equipment that was rarely available. Consequently, Tigers that broke down far from friendly lines were often destroyed by their own crews to prevent capture. Strategic mobility was non-existent by 1945. Moving Tiger units by rail required advanced planning, specialized rail cars, and intact rail lines. Allied air forces hunted Tiger transports relentlessly. Fighter bombers would spot a train carrying tanks and call in attacks. The massive, distinctive shapes of Tigers on rail cars were easily identified from the air. Many Tigers were destroyed before ever reaching the front line, bombed while sitting on trains. The tactical doctrine for employing Tigers emphasized their strengths: frontal armor and long-range firepower. Tigers were supposed to be positioned in carefully selected defensive positions with clear fields of fire extending to 2,000 meters or more. They would wait for Allied armor to advance, then destroy it, at extreme range before the Allies could return effective fire. The Tigers would then reposition before Allied artillery or airstrikes could target them. This doctrine worked well on the Eastern Front in 1943 and early 1944, when Germany still held vast territories and could choose defensive positions carefully. By 1945, with Germany compressed into an ever-shrinking territory and Allied forces advancing from all directions, this defensive doctrine became impossible to execute. There was no room to maneuver. Defensive positions were forced by geography, not chosen for tactical advantage. The Tigers became pillboxes, immobile strongpoints that fought until destroyed or abandoned when fuel ran out. Allied intelligence understood the Tiger II's strengths and weaknesses by 1945. Tactical guidance distributed to American tank crews emphasized avoiding frontal engagement with Tigers. The guidance was simple: do not fight Tigers from the front. Maneuver for side or rear shots where armor was vulnerable. Call for artillery or air support rather than engaging directly. Use numerical superiority to attack from multiple directions simultaneously. If you must fight, target the tracks to immobilize the Tiger, then bypass it or destroy it with artillery. American tank commanders learned to respect the Tiger's frontal immunity, while recognizing that a mobility kill was as effective as a destruction. An immobilized Tiger was out of the war. The crew would eventually abandon it when fuel ran out or friendly forces retreated. The effectiveness of individual Tigers in combat was often spectacular when conditions favored them. A well-positioned Tiger, with a trained crew and adequate ammunition, could destroy dozens of Allied tanks before being knocked out. Multiple accounts exist of single Tigers holding up Allied advances for hours or days, destroying tank after tank at ranges where return fire was ineffective. But these successes were tactical, not strategic. Destroying 10 Shermans did not win the war when America was building thousands of Shermans every month. Holding a crossroads for 2 days did not matter when Allied forces simply bypassed the position and continued their advance. The Tiger II that Technical Sergeant Robert Earley and Lieutenant James Morrison were observing on Highway 62 near Schwanfeld embodied all these contradictions. It sat motionless because somewhere in its complex mechanical systems something had failed. The crew had either abandoned it or were hiding nearby, waiting to see what the Americans would do. Morrison made his decision quickly. We need to investigate that vehicle, but we're not driving up to it blind. Sergeant Earley, take your squad on foot through those trees on the right flank. Circle around behind it. If there's a crew inside or an ambush waiting, I want to know before we commit the tanks. Earley nodded and moved back to gather his men. Within 10 minutes, a squad of infantry dismounted from their half-track and moved cautiously into the tree line, rifles ready, eyes scanning for German positions. Morrison watched them disappear into the foliage, then turned his attention back to the Tiger. The waiting was always the worst part. Every second felt stretched. The Tiger's gun could traverse and fire at any moment. German infantry could be dug in around the vehicle, waiting for Americans to come into range. Or the Tiger could simply be what it appeared, an abandoned hulk, broken down and left behind by a retreating enemy. 20 minutes passed with agonizing slowness. Then Early's voice crackled over the radio. "Lieutenant, we've reached the vehicle. It's abandoned. No crew, no ambush. The engine compartment is open, and there's tools scattered around. Looks like they were trying to fix something and gave up." Morrison felt the tension drain from his shoulders. "All units, advance slowly. Infantry, secure the area around that tank. Let's see what we've got." The American column moved forward cautiously, tanks spread out, infantry walking alongside with weapons ready. As they approached, the true size of the Tiger II became apparent. The Sherman tanks looked like toys next to it. Morrison's tank, weighing 33 tons and standing 9 feet tall, seemed dwarfed by the 70-ton German monster that loomed nearly 10 feet high. The gun barrel alone was longer than a Sherman was wide. Morrison dismounted and walked around the Tiger, taking in details that photographs and intelligence briefings had not conveyed. The armor plates were massive, thick slabs of steel welded at precise angles. The Zimmerit coating gave the surface a rough, textured appearance. Shell marks on the frontal armor showed where Allied rounds had struck and bounced off, leaving only scratches and dents, but no penetrations. The tracks were easily 3 feet wide, each individual track link weighing more than a man could lift. The interleaved road wheels, 9 per side in overlapping rows, looked like something from an industrial machine rather than a combat vehicle. The turret dominated the vehicle, a massive angular structure that housed the enormous gun. Morrison climbed onto the hull using the steel tow cables draped across the glacis plate as handholds. Up close, the engineering was even more impressive. Every surface showed careful design, every angle calculated for maximum protective value. The Germans had built this tank to be invincible, and from certain angles, it was. But the open engine deck told a different story. Tools lay scattered across the rear hull. A large wrench rested on the fender. Greasy rags were draped over the engine access panels. Someone had been working desperately to repair something and had failed. Morrison peered into the engine compartment and saw the problem immediately, even with his limited mechanical knowledge. One of the final drive housings showed fresh damage. Metal, shavings glittered in the grease around the drive sprocket. The Germans had suffered a final drive failure, the same mechanical breakdown that plagued Tigers throughout the war. Captain David Richardson, the battalion maintenance officer, arrived shortly after and climbed up to examine the engine. Richardson was a practical man who had kept American tanks running through 8 months of combat. He had seen every type of mechanical failure imaginable and had developed a sixth sense for determining whether a vehicle could be repaired. He studied the Tiger's engine compartment for several minutes, occasionally reaching in to touch components or rotate parts by hand. Finally, he stood and shook his head. The final drive is completely shot. The gears are stripped. We'd need to pull the entire transmission and final drive assembly, replace it with new parts, and reinstall everything. That's a factory-level repair, not something we can do in the field. Even if we had the parts, which we don't, it would take a specialized crew several days of work. Morrison had expected this answer, but still felt disappointed. The idea of capturing an intact Tiger II and somehow getting it running had been appealing, even if unrealistic. Is there anything useful we can salvage from it? Richardson nodded. The optics are worth taking. Those gun sights are better than anything we have. The radios might be useful to intelligence. We should probably take measurements and photographs for the technical intelligence people. But as a fighting vehicle, it's done. Even if we could fix this final drive, something else would break within a few miles. These things are mechanical nightmares. Over the next several hours, a small team of American soldiers crawled over the Tiger, documenting everything. An intelligence officer took hundreds of photographs from every angle. Engineers measured armor thickness at various points using special gauges. The gunner's optics were carefully removed and packed, for shipment back to ordnance specialists who would study German optical technology. The radio equipment was extracted and labeled. Ammunition was removed from the storage bins and examined. The 88mm rounds were enormous, far larger than anything American tanks fired. Several soldiers posed for photographs next to the Tiger, standing beside the tracks or sitting on the barrel to show the scale. These photographs would later appear in intelligence manuals and historical archives, visual documentation of German engineering ambition and practical failure. As the Americans worked, a small group of soldiers from the maintenance platoon began a more detailed examination of the Tiger's mechanical systems. Staff Sergeant Thomas Chen, a veteran mechanic who had worked on everything from jeeps to heavy tanks, led this investigation. Chen had a gift for understanding mechanical systems intuitively. He could listen to an engine and diagnose problems from the sound. He could feel vibrations in a transmission and know which gears were wearing out. His assessment of the Tiger II would prove remarkably accurate. Chen spent 2 hours crawling through the Tiger's interior, examining the transmission, studying the suspension, tracing fuel lines, and inspecting the engine. When he emerged, his uniform was covered in grease and his expression was thoughtful. "Sergeant, what do you think?" Morrison asked. "Could we have kept this thing running if we captured it intact?" Chen wiped his hands on a rag and considered the question carefully. "Sir, this tank is the most complicated piece of machinery I've ever seen. The transmission alone has more moving parts than our entire Sherman powertrains. The engine is beautifully built but requires constant adjustment. The suspension is an engineering marvel that's completely impractical for field maintenance. If we had captured this tank with nothing wrong, and if we had German mechanics who knew the vehicle intimately, and if we had a full stock of German spare parts, and if we had high-quality German fuel and lubricants, then maybe we could keep it running for a little while. But we don't have any of those things." Chen gestured toward the open engine compartment. "Even if we fixed this final drive, which we can't, this tank would break down again within 50 or 100 miles. Maybe sooner. The Germans designed it to be maintained by factory-trained specialists with proper tools and parts. They designed it to be transported by rail to the battlefield, fight one engagement, then return to a depot for maintenance. They didn't design it to operate continuously in the field like we operate our Shermans." Morrison understood immediately. The Tiger was a show horse, not a workhorse. It was designed for specific conditions that no longer existed in 1945. "Exactly," Chen agreed. "And that's assuming we could even move it. This thing weighs 70 tons. It would break through most bridges. It uses fuel, so fast that we'd need a dedicated fuel truck just for this one tank. It's so slow that it couldn't keep up with our advance. And if it broke down, which it would, we'd have no way to recover it. We'd have to abandon it just like the Germans did." The conversation was interrupted by the arrival of Colonel Robert Patterson, the battalion commander. Patterson was a West Point graduate who had commanded tanks since North Africa. He had a reputation for aggressive leadership tempered by practical common sense. He walked around the Tiger once, examining it with the critical eye of an experienced tanker, then climbed up to look inside the turret. After several minutes, he climbed down and gathered his officers. "Gentlemen, this is an impressive piece of engineering, but it's not a tank, it's a liability. The Germans built a vehicle that's too heavy to move efficiently, too complex to maintain in the field, too expensive to produce in quantity, and too specialized to be strategically useful. They prioritized invulnerability and firepower over everything else and created something that looks fearsome but doesn't win wars." Patterson pointed at the nearby Sherman tanks. "Our Shermans aren't invincible. German guns can penetrate them frontally, but we can build them by the thousands. We can maintain them in the field with basic tools. We can recover them when they break down. We can transport them anywhere. They're fast enough to exploit breakthroughs and reliable enough to operate continuously. 1,000 Shermans will beat 50 Tigers every time, not because each Sherman is better, but because we can actually field 1,000 Shermans and the Germans can't field 50 Tigers that all work." The officers nodded. They had all seen German tanks abandoned along roadsides throughout the advance into Germany. Panthers with transmission failures, Tigers with engine problems, Jagd Panthers with broken suspensions. The Germans built incredible machines that broke down constantly, while American vehicles, though inferior in armor and firepower, kept running. Morrison asked the question that had been bothering him. "Sir, if we know these Tigers are maintenance nightmares, why do we keep hearing about them being so dangerous?" Patterson smiled grimly. "Because when they work, and when they're properly positioned, and when they have fuel and ammunition, they're absolutely lethal. A Tiger in a good defensive position with a trained crew is nearly impossible to defeat frontally, but those conditions almost never exist anymore. The Tigers we encounter are usually broken down, out of fuel, abandoned, or crewed by inexperienced men. The myth of the Tiger is more dangerous than the actual tank at this point in the war." The discussion was interrupted by a shout from one of the soldiers searching the area around the Tiger. "Lieutenant, we found something." Morrison and several other officers hurried over to where a private was pointing at the ground near the tree line. Partially concealed under branches and debris was another Tiger too, this one showing obvious battle damage. A large hole had been punched through the side armor of the turret. Scorch marks around the hole indicated a catastrophic internal fire. The hatches were open and the interior was gutted. "This one didn't break down," the private said. "Something killed it." Richardson examined the hole carefully, measuring it and studying the penetration angle. "That's from one of ours, probably a 90mm round from a Pershing or a tank destroyer. They got a side shot and put it right through the turret. The crew probably never knew what hit them." The discovery of the second Tiger provided an interesting contrast. One had been destroyed in combat, knocked out by a side penetration that the armor could not stop. The other had simply broken down, defeated by its own mechanical complexity. Both were equally out of the war. Both represented wasted German resources and industrial capacity. Patterson made a decision. "We're not taking this tank with us. We don't have the capability to transport it, and we don't want it anyway. Intelligence has what they need. Maintenance, drain whatever fuel is left and pour it into our vehicles. Take any tools that might be useful. Then disable the gun and set demolition charges. I don't want this tank falling back into German hands if there's any counterattack, unlikely as that seems." Over the next hour, the Americans systematically stripped everything useful from both Tigers. Fuel was drained from the intact tank's massive fuel tanks, yielding nearly 200 gallons that was distributed among the American vehicles. The German fuel was high-quality gasoline, compatible with American engines. Tools were collected and distributed to maintenance crews. Personal equipment left by the German crews, including binoculars, maps, and ration containers, was gathered for intelligence evaluation. The gun breech was destroyed with thermite, grenades that melted the mechanism into useless slag. Demolition charges were placed inside the engine compartment and turret. When the charges detonated, they would ensure the Tiger could never be restored to operational condition, even if Germany somehow manufactured replacement parts. The American column prepared to move out, continuing their advance eastward. The brief encounter with the Tigers had delayed them only a few hours. Within days, the incident would be just another entry in the unit's after-action report. But for the soldiers who had examined the Tigers closely, the experience provided insights that would shape their understanding of the war's final phase. Private First Class Michael Rodriguez, who had photographed both Tigers extensively, wrote in a letter home that night, "We found 2 of Hitler's supertanks today. They were supposed to be invincible. One was knocked out by our guns, the other just broke down. I climbed inside and saw how complicated everything was. The Germans built these tanks like fine watches, but you can't keep a watch running when you're in a war zone with no parts, no fuel, and no time. Our tanks are simpler and tougher. They keep going when German tanks quit. That's why we're winning." Rodriguez's assessment, though simplified, captured the essential truth. German late-war weapons development had pursued technological sophistication at the expense of operational practicality. The Tiger II represented the apex of this philosophy. It was the most powerful tank of World War II in terms of armor and firepower, but these qualities did not translate to strategic success because the vehicle could not be produced in sufficient numbers, could not be maintained in field conditions, and could not operate for extended periods without breaking down. The American approach prioritized different values. Sherman tanks were deliberately designed to be simple enough that they could be manufactured by automobile factories converted to war production. They used commercial components wherever possible. The engine was a radial aircraft engine originally designed for civilian use. The transmission was based on automotive technology. The suspension was straightforward and easy to maintain. These design choices meant the Sherman was inferior to German heavy tanks in direct combat, but superior in every logistical and operational category. An American armored division could operate continuously for weeks because maintenance crews could keep vehicles running with basic tools and readily available parts. When a Sherman was damaged beyond field repair, a recovery vehicle could tow it to a depot, or it could be replaced from the steady stream of new vehicles arriving from factories in America. The German army had no equivalent capability by 1945. German tank divisions were wasting away because vehicles broke down faster than they could be repaired or replaced. As night fell on April 27, 1945, the American column established a defensive perimeter several miles east of Schwanfeld. Behind them, the two Tiger IIs sat abandoned in the gathering darkness. The next morning, engineers would return and detonate the demolition charges, ensuring the intact Tiger could never threaten Allied forces. The destroyed Tiger would simply be left where it sat, another piece of wreckage in a landscape increasingly littered with the debris of German defeat. For the crews who had abandoned the working Tiger, the decision to leave their vehicle behind represented a bitter recognition of reality. They had likely spent hours trying to repair the final drive failure, working with whatever tools they had while American forces advanced closer. Eventually, they faced an impossible choice: continue working and risk capture, or abandon the tank and retreat on foot. They chose survival over the machine, walking away from 70 tons of steel that had cost Germany enormous resources to build. The Tiger they left behind told a story that transcended that single vehicle. It represented a military that had prioritized qualitative superiority over quantitative adequacy. It embodied engineering excellence applied to strategic foolishness. It demonstrated how sophisticated technology becomes worthless when the infrastructure to support it collapses. It showed how the best weapon in the world becomes scrap metal when it cannot move. In the broader context of World War II's final months, the abandoned Tigers near Schwanfeld were representative of Germany's situation. The German military still possessed some of the world's most advanced weapons: jet fighters, ballistic missiles, advanced submarines, and heavy tanks. But these weapons existed in insufficient numbers, operated without adequate fuel or ammunition, and were maintained by exhausted crews with dwindling spare parts. Technological sophistication could not compensate for strategic collapse. The Americans who examined those Tigers understood they were looking at the physical manifestation of Germany's defeat. The war was not being won because Allied weapons were superior in individual combat. It was being won because Allied industry could produce weapons in vast quantities. Allied logistics could supply those weapons continuously, and Allied doctrine emphasized operational sustainability over tactical perfection. The Tiger II, for all its fearsome capabilities, had become a symbol of German desperation rather than German strength. Each Tiger represented resources that could have built multiple more useful vehicles. Each Tiger tied down maintenance personnel and spare parts that were desperately needed elsewhere. Each Tiger consumed fuel at rates that an army running on empty could not sustain. The philosophical question underlying the Tiger II's design remained relevant decades after the war ended. Is it better to have a few perfect weapons or many adequate weapons? Should military equipment prioritize maximum individual capability or operational sustainability? The German and American approaches represented opposite answers to these questions, and the outcome of the war validated the American philosophy decisively. Yet the allure of the superweapon remained powerful in military thinking. The Tiger II's reputation endured long after the last vehicle was scrapped. It appeared in documentaries, books, and popular culture as the ultimate tank, the most powerful armored vehicle of its era. This reputation was not entirely wrong. In the specific measure of frontal armor protection and main gun penetration capability, the Tiger II was indeed supreme. But wars are not won by vehicles that excel in specific measures while failing in overall utility. The soldiers who found those Tigers in April 1945 and examined them closely understood this intuitively. They appreciated the engineering skill that had created such formidable machines. They respected the crews who had fought in them. But they also recognized that mechanical complexity, while impressive, was a liability rather than an asset in sustained combat operations. The American advance continued eastward, leaving the Tigers behind. Within days, more abandoned German vehicles would be found along every road. Within weeks, Germany would surrender. The Tiger IIs would be cut up for scrap or preserved in museums as artifacts of a lost war. Their story would become a case study in how technological ambition must be balanced against practical reality, how individual excellence must serve strategic purpose, and how the perfect weapon that cannot fight is inferior to the adequate weapon that never stops. The men who climbed over those tigers and marveled at their size and power before moving on understood something fundamental. Winning wars requires weapons that work when needed, can be supplied with what's available, and keep operating despite imperfect conditions. The Tiger II was none of these things. It was a magnificent failure, a testament to engineering skill applied to flawed strategic thinking, and a reminder that complexity is not always strength. The lessons learned from encounters with abandoned Tiger IIs spread quickly through American armored units in the final weeks of the war. Intelligence officers compiled reports documenting the vehicle's mechanical vulnerabilities, and these reports circulated among tank crews who welcomed any information about German heavy armor. The message was consistent: avoid frontal engagements when possible, but recognize that Tigers were increasingly likely to be found broken down rather than operational. The psychological impact of the Tiger myth had been substantial earlier in the war, but by spring of 1945, American tankers had learned to assess the actual threat rather than the reputation. The Tiger II's operational history revealed patterns that became clearer with each abandoned vehicle discovered. Records captured after the war showed that heavy tank battalions equipped with Tiger IIs experienced catastrophic readiness rates throughout their service. The 501st Heavy Panzer Battalion, deployed to the Eastern Front in August 1944 with 45 Tiger IIs, reported that within 3 months only 12 vehicles remained operational. The others had been destroyed in combat, broken down and abandoned, or were awaiting major repairs that would never come. The 503rd Heavy Panzer Battalion fought in the Ardennes Offensive in December 1944 with 31 Tiger IIs. By the end of January 1945, only 4 were still functioning. The battalion history documented a litany of mechanical failures: final drives, transmissions, engines, and fuel systems failing under the strain of continuous operations in winter conditions. Similar patterns appeared in every unit equipped with the vehicle. The Tiger IIs sent to Hungary in early 1945 to support German defensive operations there experienced perhaps the highest failure rates of any deployment. The terrain in Hungary consisted of muddy fields and soft ground from spring thaws, exactly the conditions where the Tiger's excessive weight became crippling. Vehicles sank into mud and could not be extracted. Final drives failed from the strain of trying to move through difficult terrain. Units that started operations with 20 or more Tigers found themselves with single-digit operational numbers within weeks. The German command's continued insistence on producing Tigers, despite these operational realities, reflected a broader dysfunction in late-war German military leadership. Hitler personally interfered in weapons development and production, demanding more Tigers, even as his generals explained that the vehicles could not be supplied or maintained. The Führer had become obsessed with wonder weapons that would somehow reverse Germany's deteriorating situation, and the Tiger II fit this fantasy perfectly. It looked invincible, boasted impressive specifications, and represented German engineering superiority. That it rarely worked as intended was a reality Hitler refused to accept. Albert Speer, Germany's Minister of Armaments and War Production, documented these contradictions in his post-war memoirs. Speer had argued repeatedly for producing more medium tanks and assault guns rather than Tigers. He presented data showing that 3 Panzer IVs could be built for the resources consumed by 1 Tiger II, and that those 3 Panzer IVs would be more strategically valuable than the single heavy tank. Hitler rejected these arguments, insisting that quality must prevail over quantity. Speer's own complicity in the regime's crimes did not diminish the accuracy of his technical assessments. Germany's industrial capacity was insufficient to produce Tigers in meaningful numbers, while also supplying the army with ammunition, fuel, and basic equipment. Prioritizing Tigers meant shortages elsewhere. The symbolic importance of the Tiger in German propaganda also influenced production decisions. Newsreels showed Tigers in action, emphasizing their power and indestructibility. These propaganda films were meant to bolster civilian morale and intimidate Germany's enemies. The reality that most Tigers broke down before reaching the front or were destroyed not by enemy action but by mechanical failure never appeared in these carefully edited presentations. The propaganda value of the Tiger required continued production, even when operational reality argued against it. For the soldiers who crewed Tigers, the experience was complex. They took pride in operating the most powerful tank in the world. The prestige associated with heavy tank battalions was significant. These were elite units, theoretically equipped with the best vehicles, and receiving priority for supplies and replacements. Crews underwent specialized training and were considered the aristocracy of the Panzer forces. Yet this prestige could not overcome the frustration of constantly fighting mechanical problems. Crew accounts from after the war reveal a pattern of emotional exhaustion. Drivers described the stress of coaxing temperamental transmissions through gear changes, knowing that one mistake could strip gears and immobilize the vehicle. Commanders wrote about the anxiety of watching fuel gauges drop while uncertain whether the next supply would arrive. Gunners documented perfect shots at extreme ranges, followed by hours of maintenance to keep the gun operational. The mechanics assigned to maintain Tigers worked under impossible conditions. They were expected to perform complex repairs with inadequate tools, insufficient spare parts, and no time. A captured German maintenance report from March 1945 listed 23 Tiger IIs awaiting major repairs at a depot in Bavaria. The report noted that replacement final drives were unavailable, replacement transmissions were unavailable, and replacement engines were unavailable. The only available option was to cannibalize parts from the most damaged vehicles to keep a handful operational. The report's author noted bitterly that the depot had excellent facilities, trained mechanics, and proper tools, but none of that mattered without parts. The contrast with American maintenance operations was stark. American tank maintenance was organized around keeping vehicles operational through rapid part replacement rather than complex repairs. When a Sherman suffered an engine failure, the entire engine was pulled out and replaced with a remanufactured unit. The failed engine was shipped back to a depot where specialists would rebuild it, but the tank was back in service within hours or days rather than weeks. This approach required enormous stocks of spare parts and replacement assemblies, but American industrial capacity could provide these stocks. German forces had no equivalent system by 1945. The final drive problem that had disabled the Tiger near Schwanfeld was representative of a design flaw that German engineers never adequately solved. The Tiger II's final drives were essentially the same units used on the Panther tank, merely strengthened slightly to handle additional weight. But the Panther weighed 45 tons and its final drives already suffered from high failure rates. Installing these units in a 70-ton vehicle was asking them to handle loads they were never designed to carry. Failures were inevitable and frequent. Redesigning the final drives to properly handle the Tiger's weight would have required extensive engineering work and retooling of production facilities. This would have delayed production and increased costs. Rather than do this correctly, German engineers and production managers accepted the high failure rate as unavoidable. The decision saved time and money in the shorter term while ensuring operational failure in the field. This pattern of accepting flawed designs because proper solutions were too expensive or time-consuming appeared throughout late-war German weapons development. The economics of Tiger production revealed how distorted German priorities had become. Each Tiger II cost approximately 300,000 Reichsmarks to produce in 1944, though exact figures varied depending on what costs were included in the calculation. By comparison, a Panzer IV cost approximately 103,000 Reichsmarks and a Stooge assault gun cost approximately 82,000 Reichsmarks. For the cost of one Tiger II, Germany could have produced nearly 3 Panzer IVs or almost 4 Stooges. These less glamorous vehicles were more reliable, easier to maintain, and more strategically useful, but they lacked the psychological and propaganda appeal of the Tiger. The human cost of Germany's obsession with superweapons extended beyond the soldiers who crewed these vehicles. The workers who built Tigers in factories operated under brutal conditions in the final year of the war. Allied bombing had destroyed much of Germany's industrial infrastructure, forcing production into dispersed facilities and underground factories. These facilities used slave labor extensively, concentration camp prisoners and foreign workers, forced to build weapons for their captors. The conditions in these factories were horrific. Prisoners worked 12 or 14-hour shifts with minimal food, inadequate clothing, and no medical care. Death rates were staggering. The ethics of building weapons through slave labor would become one of the many crimes prosecuted at Nuremberg after the war. The Tiger II was literally built on suffering, the product of a regime that had lost all moral constraints. For the Allied soldiers who encountered abandoned Tigers, these ethical dimensions were not immediately apparent. They saw impressive machines left behind by a retreating enemy. Only later, as the full scope of Nazi atrocities became known, would the context of how these vehicles were produced add another layer of horror to the story. The immediate reaction was simpler: relief that such dangerous vehicles were out of action, and fascination with the engineering that had created them. Intelligence teams that examined captured Tigers provided detailed technical assessments that shaped post-war tank development. American and British engineers studied the Tiger's armor layout, noting how sloped plates maximized protection. They examined the gun and its ammunition. Learning from German ballistics research, they analyzed the suspension system, identifying both its advantages in weight distribution and its fatal flaws in maintenance accessibility. These studies influenced the next generation of tank design in Western armies. The Soviet Union captured numerous Tiger IIs on the Eastern Front and conducted similar analyses. Soviet designers were already developing heavy tanks with sloped armor and powerful guns, but examination of the Tiger II provided useful data about what to avoid as much as what to emulate. Soviet engineers noted the Tiger's mechanical complexity and over-engineering, characteristics they deliberately avoided in their own designs. The IS-2 and IS-3 heavy tanks that appeared in the final months of the war, and immediately after, showed Soviet designers had learned to combine heavy armor and powerful guns with mechanical simplicity and operational sustainability. The myth of the Tiger, particularly the Tiger II, persisted long after the war and often overshadowed the operational reality. Popular histories and films portrayed Tigers as nearly invincible superweapons that dominated battlefields. This narrative had some basis. In fact, when Tigers were properly employed by trained crews with adequate support, they were indeed formidable opponents. But the narrative usually omitted the mechanical failures, the fuel shortages, the lack of spare parts, and the crew exhaustion that characterized actual Tiger operations. The reality was less dramatic but more instructive. Veterans who had fought against Tigers offered perspectives that complicated the simple narrative of invincibility. Lieutenant Colonel William Hamburg, who commanded a tank battalion in France and Germany, recalled after the war, "We encountered Tigers maybe 4 or 5 times. Twice they were already abandoned when we found them. Once we spotted one at long range and called in artillery rather than engaging directly. The artillery destroyed it. Another time we maneuvered for a side shot and knocked it out with the 3rd round. The last time, we found one stuck in mud with the crew trying to dig it out. They surrendered without a fight." So our experience was that Tigers were dangerous if you fought them on their terms, but most of the time you didn't have to because they were already broken down, or you could outmaneuver them. Hamburg's account matched the experiences of many Allied armor officers. Tigers were threats to be taken seriously, but they were not the unstoppable monsters that propaganda and myth suggested. The combination of mechanical unreliability, limited numbers, and Allied numerical superiority meant Tigers rarely determined the outcome of engagements, let alone battles or campaigns. The German soldiers who had served in Tiger units carried complicated feelings about their experience. They had operated the most powerful tank of the war, a source of professional pride. They had received elite status and recognition, but they had also watched their sophisticated vehicles break down repeatedly, had struggled to obtain fuel and ammunition, and had ultimately lost the war despite their technological advantage. Post-war interviews with Tiger crewmen reveal a pattern of qualified pride mixed with frustration. Horst Drexler, who commanded a Tiger II in Hungary in 1945, gave a typical assessment years later. The Tiger II was an incredible machine when it worked. The gun could destroy anything. The armor made you feel safe. But it worked perhaps 60% of the time. We spent more time maintaining it than fighting with it. And near the end, We had no fuel anyway, so it didn't matter how good the tank was. We ended up blowing it up ourselves so the Russians wouldn't capture it. I was proud to command a Tiger, but I often wished we had 3 reliable Panthers instead. Drexler's wish for 3 Panthers instead of 1 Tiger, 2 echoed Albert Speer's production arguments. The soldiers understood from practical experience what the leadership refused to accept. Reliable adequacy was superior to unreliable excellence. The 3 Panthers would have provided more total combat power through their combined firepower and the probability that at least 2 would be operational at any given time. The single Tiger provided more capability in theory but less in practice. The abandoned Tigers that American forces discovered throughout Germany in April and May of 1945 told a consistent story of German defeat. These were not vehicles destroyed in heroic last stands. They were machines that had simply stopped working, left beside roads or in fields, sometimes with tools still laid out where crews had been attempting repairs. The crews had walked away, joining the streams of German soldiers retreating toward uncertain fates. The vehicles they left behind would rust and decay, eventually be cut up for scrap, or in a few cases be preserved in museums as artifacts of a war that had consumed millions of lives and destroyed a continent. For the Americans who examined these Tigers, the experience provided visceral evidence that they were witnessing the final collapse of German military power. An army that abandoned its most powerful weapons because it could no longer maintain them was an army that had lost. The Tiger IIs scattered across Germany were monuments to that defeat, expensive and sophisticated monuments to strategic failure. In the decades after the war, military analysts and historians examined the Tiger II program as a case study in flawed weapons development. The lessons identified were numerous and important. Weapons must be designed within the logistical and industrial capabilities of the nation producing them. Technological sophistication must be balanced against operational reliability. Crew training and maintenance support are as important as the weapon's inherent capabilities. Quantities matter as much as quality when conflicts extend over years. Industrial efficiency and production volume can overcome individual technical superiority. These lessons influenced Cold War military development in both NATO and Warsaw Pact nations. Tanks became more sophisticated over time, but designers consciously tried to avoid the Tiger II's failures. Reliability testing became more rigorous. Maintenance accessibility became a design priority. Logistics considerations were integrated into development from the beginning rather than treated as afterthoughts. The Tiger II served as a warning of what not to do, a cautionary tale told to new generations of military engineers and strategists. The human element of the Tiger story deserves final consideration. Every abandoned Tiger represented a crew that had tried to keep fighting despite impossible circumstances. These crews had believed in their mission, had taken pride in their vehicle, and had struggled to overcome the mechanical failures that ultimately defeated them. They were soldiers trapped in a failing system, operating weapons that their nation could no longer support, fighting for a cause that was both morally bankrupt and strategically hopeless. Their skill and courage could not overcome these fundamental problems. The Americans who found the Tigers and examined them before moving on were also part of this human story. They were young men far from home, fighting in a war they had not wanted but accepted as necessary. They had learned to respect German weapons and German soldiers even while fighting to defeat them. The Tigers, they discovered, provoked mixed reactions: fascination with the engineering, relief that such dangerous vehicles were out of action, and perhaps some sympathy for the crews who had abandoned them. The technical sergeant who first spotted the Tiger near Schwanfeld, Robert Earley, survived the war and returned to his home in Michigan. He kept photographs of that Tiger for the rest of his life, showing them to family and friends as evidence of what he had witnessed. In his old age, he would tell the story of finding that abandoned supertank and understanding that Germany was finished. The Tiger had symbolized German power earlier in the war, but by April 1945, the abandoned Tiger symbolized German collapse. Lieutenant Morrison, who had commanded the platoon that secured the vehicle, also survived and later wrote his memoirs. He devoted several pages to the Tiger encounter, using it as an example of how wars are won by logistics and sustainability rather than merely by technology. Morrison became an advocate for practical, reliable weapons systems over sophisticated but fragile ones. His arguments in post-war debates about tank development often referenced the Tiger II as an example of what to avoid. The final accounting of the Tiger II program revealed its futility clearly. 489 vehicles were produced between January 1944 and March 1945. Of these, combat records show that perhaps 150 were destroyed by enemy action. The remaining 339 were lost to mechanical failure, lack of fuel, or were destroyed by their own crews to prevent capture. The ratio was sobering. 2/3 of Tigers were not killed by the enemy, but by their own design flaws, and Germany's collapsing logistics. This represented an enormous waste of resources that Germany desperately needed elsewhere. The steel, labor, and industrial capacity consumed by the Tiger II program could have produced thousands of more useful weapons. The fuel consumed by operational Tigers could have supplied entire infantry divisions. The maintenance personnel assigned to keep Tigers running could have maintained far larger numbers of simpler vehicles. Every choice to prioritize Tigers meant shortages somewhere else in an already resource-starved military. In the end, the Tiger II demonstrated that the most powerful weapon is not always the best weapon. Power without reliability, sophistication without maintainability, and excellence without sustainability do not win wars. The Sherman tanks that American crews drove past abandoned Tigers were individually inferior by almost every measure of combat capability, but they were collectively superior by the measures that ultimately mattered. They could be built in vast numbers, supplied continuously, maintained in the field, and kept running month after month. The American tankers who examined those abandoned Tigers and then climbed back into their Shermans understood they were learning a fundamental lesson about warfare. Technology serves strategy, not the other way around. The best weapon is the one that's actually working when you need it. Simplicity and reliability often matter more than sophistication and power. These insights, purchased through years of combat and observation, shaped how militaries thought about equipment for generations. The Tiger IIs left rusting beside German roads became teaching tools, their failure more instructive than their success had ever been. The story of those abandoned Tigers resonates because it contains truths that extend beyond military history. Ambition must be matched to capability. Perfection can be the enemy of adequacy. Complexity creates vulnerability. Image can obscure reality until reality becomes unavoidable. These lessons apply far beyond tank design, but the Tiger II provides a concrete example that makes them tangible and memorable. The soldiers who found those Tigers in the final weeks of the war were witnessing more than abandoned vehicles. They were seeing the physical manifestation of a regime's delusions, the endpoint of a philosophy that had valued appearance over substance and ideology over practicality. The Tigers sat massive and impressive but utterly useless, monuments to misplaced priorities and wasted potential. And in that uselessness lay perhaps the most important lesson. Tools, no matter how impressive, are worthless if they cannot be used, and weapons, no matter how powerful, cannot change outcomes if they cannot reach the battlefield or remain in the fight. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.